Hi folks. There are other conversions that I want to teach you that have to do with the mole. But before we do that, we need to learn about molar mass so that we can do these other conversions. So there are a few different masses I want to tell you about first. So let me just go through a slide with a whole bunch of mass definitions on it. Atomic mass. Atomic mass is the average mass of one atom, just like it says in the name. Atomic mass, mass of an atom. Because atoms are very small, measuring the atomic mass, we have to use really, really small units. So we use atomic mass units, which are abbreviated AMU. Formula mass. A formula mass is the average mass of one formula. What do I mean by one formula? Well, if it's a covalent compound, I mean one molecule. What is the mass of one molecule? If we're talking about an ionic compound, then I'm talking about a formula unit, the lowest ratio of atoms in an ionic compound. Again, a molecule or a formula unit is very, very small, so we're still measuring formula mass in atomic mass units. Molar mass is the mass of one mole. Remember, a mole is huge. Molar mass is nice because it's a word that applies to both elements and compounds. It doesn't matter if it's ionic or if it's covalent, the word molar mass works for it because you can have 1 mole of anything. Any type of particle. It can be atoms, molecules, or formula units. As I said, these units are big. They're given in grams per mole because a mole is that huge number, 6.022 times 10 to the 23rd. So grams. Now we're measuring units in grams per mole. This is going to make it useful as a conversion factor. We're going to be able to figure out how much a mole weighs, what the mass of a mole is, by using this molar mass conversion factor. So that's what makes this so convenient. So any of these masses that I've discussed can be calculated by adding together the atomic masses for any atom that appears in the formula. Please, when you are doing these calculations, always round your masses to 2 decimal places off of the periodic table. Some of the values on the periodic table are written to 3 decimal places, some are written to 2 decimal places, and my self-check spreadsheets are going to be based off of rounding them all to 2 decimal places. So please round to 2 decimal places. Be sure to choose the correct units for the correct situation. So if it's the atomic mass or the formula mass, you're going to use atomic mass units. If it is molar mass, you're going to use grams per mole. So let's work through a couple examples of this. Carbon and iron. For carbon, the formula for carbon is C. It's not a diatomic element or anything like that. So we just have to worry about 1 atom of carbon. We can talk about its atomic mass or we can talk about its molar mass. If we talk about its atomic mass, we look at the periodic table, we see that the value is 12.01 for the mass. If we're talking about atomic mass, that's 12.01 AMU, atomic mass units. But if we're talking about molar mass, the numeric value is still 12.01, but we switch up the units. We say it's grams per mole because a mole is huge. You have billions and billions and billions and billions of particles. So we measure that mass in grams per mole. So you pause the video and see what the answers are for iron when you calculate the atomic mass and the molar mass. Hopefully you found that 55.85 in atomic mass units is the correct mass to give for iron for the atomic mass. But for molar mass, that would be 55.85 grams per mole. Notice that this is rounded. The periodic tables that I've given you have that list the mass as 55.845, 0.845, but we've rounded that up at 2 decimal places. And because this number is 5 and up, we've rounded up. Let's just stick with molar mass examples now, because this is what we will use most for our calculations. Let's look at water first. The formula for water is H2O, and that means that we have 2 hydrogen atoms and 1 oxygen atom. So if I want to know the molar mass of water, I need to think about my 2 hydrogen atoms, and looking at my periodic table, each hydrogen atom has a mass of 1.01 grams per mole. And then I add in the mass of my 1 oxygen atom, which is 16.00 grams per mole. Remember that we don't write the number 1 in the formula, but we wouldn't write down the letter O unless we had at least 1 oxygen in the molecule. If you do the math and add that all together, then you get 18.02 grams per mole for this molar mass for water. Let's look at oxygen next. The formula for oxygen is O2. That makes it different to the examples we did on the previous slide, where we had just iron or just carbon. Oxygen is a diatomic element. If you don't remember your diatomic elements, you need to. These are the 7 diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Whenever you write these as an individual element, you have to have 2 atoms in the formula. Because there are 2 atoms of oxygen in the formula, then to calculate the molar mass, we have to take into account both of those. So 16 plus 16 is going to give us 32 grams per mole. More molar mass examples. Sodium carbonate. Thinking about the formula for sodium carbonate, sodium has a charge of +1 and carbonate has a charge of -2. So the correct formula at the end is Na2CO3. Taking all of those atoms into account, we have 2 sodium atoms. So 2 times 22.99 from the periodic table, 12.01 for my 1 carbon, and then 3 times 16 for my 3 oxygens. Adding all of those together gives me 105.99 grams per mole. One more example, we have iron 2 phosphate. The correct formula, remember, iron has a charge of 2, phosphate is PO4 with a charge of -3, so the correct final formula is Fe3PO4 2. The tricky thing here is just keeping track of how many of each atom we have. There are 3 irons. There are 2 of the whole phosphate ion, which means we have 2 phosphoruses, and we have 2 times 4 is 8 oxygens. So calculating the molar mass, we would have 3 times the molar mass for iron, 55.85, plus 2 times the molar mass for phosphorus, 30.97, plus 8 times 16, the molar mass for oxygen. So doing the math and adding that all up together, you would get 357.49 grams per mole. So this is how you go about calculating molar mass for simple examples like atoms or more complicated examples like molecules. I hope this helped.